Hello everyone, welcome back to another STEM Helps video. Today we'll be talking about motion and how to apply these three formulas into any problem that you find with respect to motion. Let's start off simple. We'll be using the first equation. Let's say we have a car and it's speeding down the highway. Let me draw a relatively smooth line. And here's my car. It's going to be just a box. Just give me a box so we can, and let's have some wheels on it. And here it says u is initial velocity. Well, I'm going to change this to v of 0, and we have v final. I'm going to say this to v of f. So initial velocity is v sub o, final velocity is v sub f. All right. So v of f, let's say this car starts out at, I don't know, let's see, he starts out, v of 0 is going to be 15 meters per second. V final, oops, that's too big, v final is going to be 45 meters per second. So that means when he's starting off at 15 meters per second, he's going along down this road, and v final, he's at 45. And it says also that our time is going to be equal to 6 seconds. Now, we can solve this. Here, let me change this to a different color. We can solve this using this formula. V final equals V initial plus AT. Here, V final is 45. So let's say 45 equals 15 plus, here, let me see, plus 6 seconds times A. And we're trying to find what A is. We're trying to see how fast he accelerated. So we can use a bit of algebra. We want to have 6A to one side. Let me make this into an actual 6. So we subtract 15 from both sides, and the left-hand side will be 30 equals 6A. And we can divide 6 from both sides, and we get that A is equal to 5. A equals 5. And now we need to make sure that the conversions or unit conversions are all similar. Meters per second squared. Let's try another one. In this case, they have s, which is a new variable. It's not on this list, but it is called position. Let me write this over here. As s is going to be position. Oops. Position. And let's take a glance at it one more time just so we know what to do. Position is equal to the initial velocity times time plus this entire thing, half times the acceleration times time squared. Time squared because meters per second squared. So the just half of the meter times and initial velocity is meters per second, and time times meters per second will just give meters. So position is going to be, the unit is going to be in meters. So let's say we have a problem where I give you the position. I give you the position as position is equal to 24 24 meters, I have the initial velocity v0, and remember that the formula gave it a bit weird. It was a u, but in my case it's v sub 0. It is going to be, okay, let's come up with a good number, -1. We start off going backwards. It's a very bit strange. And now we have, I actually feel like we should change this to make it more simple and not as complicated. We shouldn't have this as -1. Instead, what we're going to do is we're going to make this equal to -2, even more obscure. Let's just make this 2. And finally, the acceleration is -1. And then we put the meters per second and meters per second squared. So he's decelerating. His initial velocity is 2 meters per second. And what will be the time when he is 24 meters from where he is? So we're thinking of this as he is, let's say we have a ramp. Not a ramp. Let's say we have just a straight road, and you're going your car, box with 2 wheels, and you are decelerating. Your acceleration is negative. How long will it take you to go from position 0, to 24? And we have all the components here in our chart here. Okay, so let's write it down. S equals, so 24 equals the initial velocity 2t plus 1/2, a is -1, t squared. This seems very familiar. Hopefully you guys will recognize that this is just solving a quadratic formula. And in solving a quadratic formula, the first thing that you want to do is setting one of the sides equal to 0. So this has more components to it, so it's just much easier to just subtract 24 from the right hand side. So it's going to be equal to 0 equals -1/2 t squared plus 2t minus 24. And negative numbers and this fraction is a bit scary, so let's remove those. Okay, let's pick a different color. So let's say 0 equals, multiply everything by -2. So when you multiply this by -2, let's do that. -2, negative times negative is positive. It's a positive number, and 2 times 1/2 is just 1. So 1. Let's make this bigger. 1t squared plus 2t. We're multiplying by -2. A positive times a negative is going to be negative. 2 times 2 is 4t. -24 times -2 is positive 48. And now what we're going to do is we're going to try and solve this. I'm just going to tell you now that there isn't any good whole number answers. So let's just go ahead and do the quadratic formula. So instead of x, we say t is equal to -4, so -b 4 plus or minus the square root of 4 squared minus 4 times 48 times 1. So 4 times 48 times 1, all divided by 2, because 1 times 2 is 2. So just by looks of it, 48 in of itself is greater than 16. So 4 times 48 will definitely give an imaginary number. So even though in math class we have to solve for this, we can just stop there. We can say that t does not exist. It's imaginary. Time is imaginary in this scenario. If you're going 2 meters per second and you're decelerating 1 meter per every second squared, well, think about it. If we go 1 meter slower every second, right? After 2 meters, you're going to be 0 and start going backwards. There's never going to be a time where you hit 24. And I hope that's helpful.